All right. Now it should be Thursday, January 19th. And we are going to go over graphing with the transformation rules. So using everything that we should know right now and how to best do it in step by step. The parent function, when you see anything raised to the second power, the parent function is going to be x squared. So the question is, what transformations are happening to the parent x squared as we move along? As we see, we should see that there are 1, 2, 3 things happening to the parent. And we're going to take care of those here. All right, so the first thing we're going to do is graph the parent function. And that parent function has an axis of symmetry at 0. Its vertex is 0, 0, over 1 up 1, over 2 up 4, over 3 up 9. And the same thing happens on the other side, and we graph it as well as we can. All right, there it is. So the first transformation that happens is we have plus 5, which means we are going to go left 5 units. So that will move our axis of symmetry to -5. Everything else is the same from there. The vertex is right there on the x-axis. Over 1 up 1, over 2 up 4, over 3 up 9. And the same thing on the other side. There we go. The next, it says you have a negative out front, which is going to be reflection over x-axis. Remember, that changes your y when we flip it over the x-axis. So our axis of symmetry is still in the same place. Our vertex is still right there on the line, but now instead of opening up, it's going to open down. Instead of going up 1, it's down 1. Instead of going up 4, it's down 4, and then down 9 when you're 3 away. 3 away, 2 away, 1 away. And that one's off a little bit. It's not terrible. All right, there we go. And the last thing it says to do is go down 2. Does it still have that? Nope. So -5 is still there. And now we're going to go down 2 units. So the vertex is no longer on the x-axis. It's down 2. And I'm going to go down 1, or over 1, down 1, over 2, 2 squared is 4. So down 4, over 2, down 3, which is 9, which is off of the graph that we've been provided. And there we have it. That is our final picture. You can see the vertex should be at -5, 2, opening down, and that's what we have. We're just doing these in step-by-step things. So again, the first one, y equals x squared. I should just copy all of the one above it. Ooh. Let's do that. Clone. Oh, it didn't grab it all. Exit, back up. Let's see if I can bring it all with me. Nope. Alright. Looks like I'm going to have to do it. So, axis of symmetry, right there at 0. Vertex at 0, 0. Over 1 up 1, over 2 up 4, over 3 up 9. Same thing happens on the left. Looks like we're going to do that for every problem that we have to do, putting in that parent. The first transformation, we have a negative inside. So it's going to reflect, that's this negative, reflect over y-axis. The picture will not change at all because really the left portion, this left portion right here of the graph is going to become the right portion of this graph. But it's going to look the same. So 0, 0, 1, 1, 2, 4, 3, 9. That's the old left half. And this half over here will be what was once the right half. But when you graph them together, you're going to get the same exact picture. All right, the next thing we have is a vertical compression. We have a vertical compression by a factor of 2. Because what are we doing? We're dividing all the y values by 2. They're going to be half of what they once were. So, put my axis of symmetry in again. It's there. I forgot it here on the other one, but now it's in. All right, so there we have it. And now I want everything to be half of what it once was. 0, half of 0 stays 0. Half of 1 is a half. Half of 4, when I go over 2, half of 4 is 2. When I go over 3, it was 9. This height from the second graph was 9, so now half of 9 is 4 and a half. So I will be up here. And I might have enough room for the next, and I do, because 4 squared is 16. Half of that is 8. 5 squared is 25. Half of that is 12 and a half. That is off of the graph that we've been provided. So there is our picture. And now the last thing to do is go down 4. So we are going to, what is this? We have a vertical shift. Many of us are just going to say down 2. Going down does not change that axis of symmetry. It's still here at 0. X equals 0. But now our vertex is going to be here. Each point is going to be down 2 from where it was. So there's the half away. This is 2 away. And 3 was 4 and a half. So 1, 2, 3, 4 and a half. And I go 4 away, that's 16. So half of that is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And now we've got more points on the graph. And graph it the best you can. There you go. Brings us to the third problem. Same exact parent. That is y equals x squared. We have an axis of symmetry here at x equals 0. The vertex is at 0, 0. Over 1 up 1. Over 2 up 4. Over 3 up 9. And now we graph them. The first transformation, we've got a 2 out front. So we're going to multiply everything times 2. We're going to double the distance from the x-axis away. The axis of symmetry stays here. So we go 0, 0. 1 away was 1, double that. I'm now 2 away. 2 away was 4, double that. It's now 8 away. Anything else will be off the graph. So that took care of our vertical stretch by factor of 2. All right, so the next thing we have is the negative. So we are going to reflect over x-axis. Same axis of symmetry. I have not moved this left or right at all. So 0, 0 stays. 0, 0 stays. But now instead of going up, it's going to go down. So I'm going to go down 2. And then down 8. So now we've taken care of the vertical stretch and the reflection. The only thing left to do is move this up 5 units. Same exact axis of symmetry. I have not moved left or right at all. The x's haven't changed. There is no change in by the x squared. So now just move everything up. So 2 away. 2 away here. And then I need to go 8 away, which would be here. And now I probably have room. If I go 3 away, 3 squared is 9 times 2 is 18. Nope, don't have room. This just looks weird though. What do we got there? This point going up 5, it did. 8, oh, that's what's wrong. That should be there. Now that looks better. Yes. All right, yeah, because that distance 2 away is 4, and then that should be 8. 1, 2, 3, 4, 5, 6, 7. That is 8 away from the vertex, so we're good. All right. There it is. Let's flip it over and do the last ones. Really just one more to do like that. It's got 3 steps. Looks like we're going to first move this thing left or right because there is a change inside. So let's write the parent down. Y equals x squared, which is going to give us the axis of symmetry right there at 0. The point 0, 0, 1, 1, 2, 4, 3, 9. You should be getting used to those points. And graph the parabola. All right, so now we have a horizontal shift. We are going to go right 4 units. So that will move our axis of symmetry. And everything else is the same. The vertex is right there on the x-axis. Go 1 away, 2 away is 4, 3 away is 9. So we have just taken the same exact shape and moved it over. I mean, I should be able to, if I did it right, just cover that one up. All right, I'll put it back. That wasn't too bad. All right. Moving on. Let's now take care of that number on the outside. This 3 is outside, so that is a vertical, either stretch or compression. Since the number is greater than 1, that is a vertical stretch by factor of 3. That factor is always, what are you multiplying by? It is 3. All right, so my axis of symmetry will remain at 4. 0 is still 0 away, but 1 away was 1. Now it's 3. 2 away was 4. Times 3 is 12. That's off the graph. So we need that to open up about as narrow as possible. There it is. And the last thing to do is take care of that. A +1 tells us that we are going to move this up 1. Axis of symmetry, still at -4. But my vertex is now no longer on the x-axis, it's been moved up 1. When I go 2 away, times 3, 1, 2, 3, and anything else is off the graph. So there is the picture. As you can see, the vertex, when you go back to the original problem, could we have skipped all those steps and gone right to the end? Absolutely, but we want you to see what's happening step by step. The vertex should be at 4, -1. Well, I'm sorry, 4, +1. And it is. The vertex should be right there, and from there everything is tripled away because of the 3 that was out front. All right. The graph of the parent quadratic function and a transformation of a parent function are given. List the transformations that occurred and then write the equation of the transformed function in vertex form. Whew, that was a bunch. So, let's first look at the original function. It's this one. I mean, I could look and go, okay, if I just move this over and down, that's going to sit perfectly. So we don't have a compression or a stretch. This is the same exact graph, just moved a little bit left and a little bit down. So the transformations, well, what's it say it wants us to do first? It wants us to write down the equation, let's see, of the new one. Yeah, it looks like they want us on this graph to write that equation, which would be easy. Y equals, well, let's do it in a different color so it matches the graph. Since I did the other one in blue, we all know that this is just y equals x squared. But in vertex form, the new one, it is going to be at y equals x plus 3, because it has gone right 3, and it has gone so squared and then down 4. We have no vertical stretch, so we don't have to worry about that. But that will give us this vertex, -3, -4. Over 1, up 1, over 2, up 4. Same things happen on both sides, so there is no stretch. So again, in order, this was left 3, and then down 4. All right, the next one, the parent, again, is y equals x squared. Looks like this. What is happening? Well, it has moved. So let's write this down. The new vertex is at 4, 3. So we should have x minus 4 squared plus 3. It is opening down. So we should have a negative out front. So we should see, by writing that vertex down, our axis of symmetry has gone from here and right 4. We've already taken care of that. Now let's look at this gap. When we go 1 away, no longer are we going 1 down. It's going down 2, so it has stretched by a factor of 2. So not only do we want a negative out front, we want a -2 out front. So what are these transformations? First, we will say right 4 takes care of the inside. Second, we will say it's got a vertical stretch by a factor of 2. By a factor of 2. Next, it reflects over x-axis. And let's be real, I would not take off points if these two were switched, because it really doesn't matter if you reflect it and then stretch it, or stretch it then reflect it. I usually just keep moving outside. I start here in the middle, then I take care of that, then this, and then at the end we do the vertical shift. So the last thing is step 4, we are going up 3 units. And we're done. Last problem. Number 7, transformations. All right. Again, our basic graph is y equals x squared, and that is this guy. Our new one has been moved left 5. We've got this axis of symmetry that was sitting here. It's been moved left 5 units. So right away, we should be able to say y equals, and then x plus 5 squared. It has also been moved down 2 units. So I can put minus 2. It's still opening up, so it's positive. But now, when we go 1 away, I'm not going up a full 1. It's half of what it used to be. So this is going to have a coefficient out front where a is 1/2. All right, so let's label these things. So 1, we are going left 5 units. 2, we have a vertical either stretch or compression. Since the number out front is 1/2, that is a compression. It's between 0 and 1. Vertical compression. And anytime we say compression, that tells us we're dividing. What are we dividing by? By a factor of 2, because we're dividing by 2. That's what 1/2 is. And finally, the last step, we move down 2 units. And that's it. Your homework tonight is work on the practice on this lesson and do all you can. Again, all the answers as well as these notes are online. Tomorrow it will be Friday, and the sub is going to pass to you your unit review. Don't get all excited and think, oh my goodness, I can't believe I'm getting it already. That's okay. Tomorrow's assignment is only the first page, front and back. I will see you guys on Monday. Have a great weekend. Bye-bye.